Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about classifications of binary codes. We're going to see different types of binary codes and how it is represented. And specifically you'll see more about BCD codes, XS3 codes, gray codes. And before starting with, we all know what is binary codes, right? We know that binary numbers are zeros and ones. And to represent any decimal system to binary or any hexadecimal to binary, you will use this type of codes, right? 421 code and 8421 code, right? So these are called binary codes, and these binary codes can be classified into weighted binary codes, non-weighted codes, alphanumeric codes, and error detection codes. Weighted binary codes is something which we normally use. Okay, so there are a lot of weighted binary codes, which is BCD, binary coded decimal, that is 8421 code, 5421 code, 2421 and 8421. 84 minus 2 and minus 1. Right. This is weighted binary codes. And you ought to understand what is weighted binary codes. Right. For example, if you want to represent 9. 9 எப்படி represent பண்ணுவோம் 8421 ல அப்படினு பாத்தீங்க அப்படினா 0 sorry 1 0 0 1. This is how you represent 9 in 8421 code, right? So which means this is 8 and this is 0 0 and 1. That is 8421 ல, right? So this is 8 and this is 1, another 2 is 0. So 8 plus 1, that is 9. So which means each bit corresponds to its weight, right? Each bit will obey the position weighting principle. That is called as weighted binary codes, right? So all these codes 8421, 5421, 2421, everything is weighted binary codes, right? What is non-weighted codes? Non-weighted codes in the sense each bit will not correspond to the weight. It will not obey the positional weighting principle. For example, in XS3 code, normally 0 will be represented as 0 0 0 0 in binary, right? Even in 8421 code, you will represent 0 as 0 0 0 0, right? So this is weighted binary code. Now for non-weighted code, for XS3 code, 0 will be represented as 0 0 1 1, right? That is in excess of 3. I'll explain what is XS3 code later, but for 0 you will represent as 0 0 1 1. So which means here the bit position is not obeyed here. The weight of the bit position is not obeyed here. Okay. So 0, if you add all this one, it will not come 0. Right. So that is called as non-weighted codes. And different types of non-weighted codes is XS3 code and gray code. And similarly, there is other codes which is called as alphanumeric codes, which is called ASCII codes. That is American Standard Code for Information Interchange. Like in computers, if you want to represent alphabets, special characters, numbers, everything can be represented using this alphanumeric codes. And we'll see that later. And what is error detection codes? In order to detect the errors, if your message is transmitted and if it is received at the receiver end, at the receiver system, we have to make sure that the received message is correct or not. In order to check whether the received message is correct or not, error detection codes are used. Okay, and this is a very good example for weighted codes and non-weighted codes. So this is 2 and 4. 2 can be represented as 0 0 1 0 and 4 can be represented as 0 1 0 0. Right, and as I said, this follows 8421 code and this also written in 8421 code. If we combine all these things, it will be equal to 2. And if you add all these things, this will be equal to 4. So this is positional weights, right? So this is positional weights and the bits corresponds to this positional weights. It obeys that positional weights. That is called as weighted binary codes. Okay. And now we'll see how to represent a normal decimal number in various binary codes. Okay. So it is same like 8421 code. Like you all normally know how to represent 8421 code. For 0, you will represent 0 0 0 and for 1, you will 0 0 0 1. That is by using this 8421 code, right? If you add all these things, it will be equal to 1. If you add all the things, it will be equal to 2. And if you add all these things, it will be equal to 3. and 4, and similarly 5, 6, 7. This we know this normally, right? Similarly, you have other codes as well. So other BCD codes like 2421, 5211, and 8421 code. Okay, you can represent same 0 like this way, and 1 2421. You can write 2421, and you can represent 1 as like this, and for 2 you can represent like this, or you can represent like this, right? Which means in these codes, right, one particular decimal value can be represented in 2 or different ways. Okay, but according to 8421 code, you can represent in only one representation. That is, 1 can be represented in only one way, 2 can be represented in only one way. But in these three codes, one number can be represented in 2 or more forms. Okay, and you can see 2 can be represented like this. And similarly, if you want to represent 6, right, how can you represent in 2421? It can be represented as 0, 1, 1, 0. This is 6, right? And similarly, this is also 6. This is also 6, correct? So 1 or 2 bits can be represented, will have more than one representation in these 2 bits, right? Similarly, 5211 code, you can represent this way, 0, 0, and similarly 1, and this is 2, and this is 3, right? And 4, and 5 like this. Okay, so you can follow the same rules as 8421 code, and only thing is certain numbers can be represented in different ways. Okay, so that is the advantage of 2421 and 5211. Similarly, you have another set of code which is 84 minus 2 minus 1 code. This is minus 2 and minus 1. So you can write these codes in the same way, right? For example, if you want to represent 1, so how will you represent 1? You can see it is 8, 4, minus 2 and minus 1. So this is 0. So if you want to represent 1, what I can do is this is 1, this is 1, and this is 1. That is 4 and minus 3. So I will get 1, correct? So this is 4 and minus 2 minus 1. So it will get 1. Like that you can represent, right? For example, if I want to represent 2, what I can do is I can represent 0, 1, 1, 0. That is 4 minus 2, it will be 2. Like that you can follow this one, right? 8, 4 minus 2 minus 1. Okay, so these are weighted codes. So if you take any particular value, any particular bits, it will correspond to the position of that particular bit, right? Weight of that position. Okay, and now I'll tell what is XS3 code. Just I'll tell what is XS3 code. From the name itself, you can understand XS3 code is nothing but, like, for any decimal value or any binary value, you have to add plus 3 to that, right? For example, if it is 0, then it is 0 plus 3. That is XS code. In binary or decimal, if it is 0, in XS3 it will be 3, right? And if it is 1, in XS3 it will be 4 plus 3. And if it is 2, it will be plus 3, 5. And if it is 3, it will be plus 3, 6. And you can see here, for 0, it is represented as, use the same 8421, 8421. Okay, for 0, it is represented as 3, right? And for 1, it's 4. And for 2, it's 5, 6, 7, 8, 9, 10, right? But don't understand that this has 3, 4, 5. This is 0, 1, 2, 3. That is, 0 can be represented in XS3 as 0, 0, 1, 1. And similarly, 1 can be represented as 0, 1, 0, 0. And 2 can be represented as 0, 1, 0, 1. Right? Like that it goes on. Right? Now you understand what is weighted codes and what is non-weighted codes. Right? Right. Similarly, using these codes can be of different types. That is, we can say that as a reflective codes, or we can also say that as a sequential codes. Right? What is meant by reflective codes? Reflective codes, in the sense, every codes can be said as reflective if it obey one particular rule. That is, if the 9th bit, that is, if the 9th code is the complement of 0, right? And if your 8th bit is the complement of 1, and if your 7th bit is the complement of 2, like that, right? That is, 7th bit in the sense 7th representation. For example, we can say codes 2421, 5211 and XS3 are reflective codes. That is, you can see this tabulation. You can see for 2421, 0 is represented as 000. And if you see 9, it will be the complement of 0, right? It is complement of 0, right? So you can see here for 0 everything is 0 and for 9 it is everything is 1. So it is complement of 0, right? And similarly if you take 8, so this is 1110 and if you see 1 it will be complement of 8. So this is 0001, that is you will have zeros in all the 1 position and 1 in all 0 position in this, right? Similarly for 7 you have to compare with 2 and similarly 6 you have to compare with 3, right? So if it is complement of this particular numbers, that is 9 0 is complement, and if it is 8 and 1 is complement, and if it is 7 and 2 is complement, then those codes are called as reflective codes. Okay, and similarly what is sequential codes? Sequential codes is very simple. In binary representation, if you take any 2 subsequent codes, that 2 codes will be differing by 1 particular bit, right? If you take this particular 8421, most of this bits will be, most of the consecutive numbers will be represented, will be differentiated by 1 bit. You can see here the difference is 1 bit, right? And similarly difference will be 1 bit, that is 1 bit will be changed, each and every one bit will be changed in subsequent numbers, right? So that is called as sequential codes, and I already explained what is non-weighted codes, right? So non-weighted codes, it doesn't follow the positioning weighting principle, right? And very good example is XS3 codes, right? And you can see, as I said, XS3 codes is the same what we explained there. That is, for every number you have to add 3 plus 3, that's all, right? For if it is binary, you have to represent, you have to add 0011, and if it is decimal, you can just write 0 plus 3 and 6 plus 3 is 9, something like that, right? So that is XS3 code. Any code in excess of 3, right? If it is 0, 0 plus 3, 1, it's 1 plus 3, like that, okay? And there is another non-weighted code which is gray code. Gray code is another interesting topic. We will see a clear video about gray code. Okay, gray code is a very good example. It is used in analog to digital converters mostly. Okay, and it is also a non-weighted codes. Non-weighted codes in the sense, like it will not follow the weighting principle like XS3 codes, and you have unique representation for gray code. You cannot directly represent the binary number using gray code like XS3 code. It is not very simple. You have separate calculation for that. Okay, as of now, understand that gray code is another non-weighted code. Okay, and gray code is also a reflective digital code. Okay, and you can see that any 2 subsequent numbers in gray code will be differing by only 1 bit. It is a sequential code. Okay, so it cannot be also called as reflective digital code, which has the special property because 2 sequent numbers can be differ by only 1 bit. Okay, so this is about gray codes. Okay, so today what we have seen is, we have seen what are the different classifications. Just like I said, what are the different classifications? Okay, we have seen what is weighted codes, what is non-weighted codes, and what is gray code, what is XS3 codes, and what is reflective codes, and what is successive codes. Okay, so this is just a basic introduction. Hope you understand. Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.